All right, guys. This is going to be a quick review lesson on the sine law. I'm not sure why that's written so small. Let's see if I can adjust that a little bit. What looks nice on this? Maybe a blue? Oh yeah, looks cool. The sine law. Stuff that you've already seen in the course. It's based on the fact that for any triangle ABC, you use capital letters for the vertices, the points on the triangle, and you use lowercase for the sides. So the sine law basically says this, that the sine of angle A, that would be the angle right here, divided by its opposite side. Now notice that the angle A, its opposite side is lowercase a, is equal to the sine of angle B, that would be right here, and there's its opposite side, lowercase b, and then the same relationship with C. That is the sine law. The rest of this lesson is just examples using the sine law. It says determine the length of side B. Well, first of all, we need to know where side B is. Here's angle B, 44 degrees. So the opposite side is side B. We want that side right there. Now, before I do this, I should tell you, go back here and say that this is completely reversible as well. I'm just noticing that we may need that in the first example. I can put the lowercase, the side lengths on the top, and the sine angles on the bottom. Works just the same. And since we're solving for a side length, I'm going to do that. I'm going to say B divided by sine 44 degrees is equal to, now we got to choose, right? And you're going to want to choose a combination that you know, angle C, side C. Don't use A, that makes no sense because you don't know side A. So side C is 15 divided by sine of angle C, which is 71 degrees. So what you do, well, there's lots of ways you can do it. I think that the easiest way to do it is to multiply both sides by sine 44, because that gets rid of that. And then you just have B equals 15 times sine 44 divided by sine 71 degrees, all right? And on my calculator, that goes 15 times sine 44. Some of your calculators, you have to type in the 44 before the sine, but that's pretty rare. Divided by sine 71 is equal to 11. So side length B is 11. I typed it into my calculator just like that. Next one, determine the length of side Q. Side Q will be opposite point Q. Unfortunately, I don't know angle Q in order to do this. So I would love to set it up with Q divided by sine of Q equals, and then use some other combination. Looks like P. So I'm going to say side P divided by sine of angle P, because I know the angle and the side. But before I can do anything, I need to figure out what that angle is. Well, I've got 30 and I've got 12. All the angles in a triangle have to add to 180 degrees. So 30 plus 112 plus whatever angle Q is equals 180. So I'm going to type in 180 minus 112 minus 30, and that gives me 38 degrees right there. Now I'm ready to roll. So side Q divided by sine 38 degrees is equal to side P, which is 14, divided by sine of angle P, which is 30 degrees. Same as before, I'm going to multiply both sides by sine 38 times sine 38. That gets rid of it, and side Q is equal to 14 times sine 38 divided by sine 30. Typing it in my calculator just as I see it, 14 times sine 38. Again, some of your calculators will have that reversed, divided by sine 30. And that side length over there is 17 point something, but I've rounded my answer to 17. Let's try this one. Determine the measure of angle D. So that's right here. I want to figure out what that angle is. So now when I'm finding the angle, I want to reverse the formula. I want to go, okay, so sine angle D over side D is equal to, do I know another combination? Yes, E and E. So it's going to be sine of angle E over side E. Sine D over side D is 6, equals sine angle E, so that's sine 52 divided by 8. So it goes kind of like before. I'm going to go times 6 times 6. That gets rid of the 6. And then I'm going to have sine D is equal to, well, I'm going to have all that. I'm going to have sine 52 times 6 divided by 8. And it gives me 0.591. So the last thing I got to do is I got to get the sine over there. And the way to do that is just like before, it has to be the second function or shift sign. So I got to go shift sine 0.591, which is 36. The answer is 36 degrees. Does that look like a 36-degree angle over here? I'm going to say yes, it does, because the math doesn't lie, unless you do it wrong, of course. One more on the sine law. It says completely solve the triangle, but I'm not going to do that. Let's just pick an angle to solve for, okay? Let's solve for this angle right here, Z. So let's say sine of Z divided by 21. I'm going to go right into numbers. That's its opposite side, is equal to sine 84 over 27. There's the 84 opposite the 27. You're going to multiply both sides by 21 times by 21. You're going to end up with sine Z equals, I'm going sine 84 times 21 divided by 27. It gives me 0.7735 and some other stuff. I've got that number in my calculator. I'm going to do that shift sign. Where is that shift sign? And I'm going to find that angle Z is equal to 51 degrees. It was actually 50 point something, but I rounded that up to the nearest degree, 51. All right, so let's keep those annotations because you never know when they might come in handy. That was the end of that PowerPoint anyways. And let's move over to the cosine law. The cosine law. Open that up. And same idea, triangle ABC, sides ABC. And the cosine law goes like this. It'll remind you of Pythagorean theorem. It's c squared equals a squared plus b squared. And that would be Pythagorean theorem, but it's minus 2ab, that's 2 times a times b, times the cosine of angle C. Right? And you can use this for any side, just have to label it a little differently. You can find any side with that stuff, but once in a while you're trying to find the angle instead of the side, in which case it ends up being, let's see if I can rearrange that for you on the fly. That's going to be c squared minus a squared minus b squared divided by negative 2ab. And then, of course, you would have to do the inverse cosine thing, or the second function cosine to finish it off. But that, in a nutshell, would work for you. If you want to, instead of trying to rearrange it yourself every time, that would work. All right, determine the length of side A. No problem. That's going to be right here. Side A is right here. So you start with that. So let's go a squared equals, I should label that as lowercase a. A squared equals, and you add the other two together, b squared plus c squared. In that case, it doesn't work exactly like Pythagorean theorem. Minus 2bc, so it's just the other two sides, times the cosine of angle A. That's the 72. So it's going to be a squared equals, I'm going to try and cram all this into here. What's side B? 17 14 minus 2 times 17 times 14 times the cosine of 72 degrees. Now, if you're good enough with your calculator, you should be able to punch all this in one step. Just listen to what I do. 17 squared, should have a squared button on your calculator, plus 14 squared minus 2 times 17 times 14 times cos 72. And it gives me 337.9, and there's some other stuff there too. Now that doesn't make sense for the side length, right? And that's because we haven't dealt with that squared yet. And what you have to do is square root. If a squared equals 337, then a equals the square root of 337.9. So I'm just hitting my square root button on that, and I get that the side length a is about 18. I rounded that off. It was 18 point something. So that's how the cosine law works. Let's keep going with these. Let's find the side length q, same idea. So that's going to be q squared equals the other two sides squared, 8 squared plus 11 squared minus 2 times 8 times 8 times 11 times the cosine of 53 degrees. Type it all in my calculator. 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of 53. And it gives me 79 point something. So q squared equals 79.080 and some other stuff. But again, you got to take the square root of that. Q equals the square root of 79.080 and some other stuff. So I'm just hitting my square root button on that. And I find that q is equal to 8 decimal 9. There's no units on that. And does that look like an 8.9? No, I would say it looks longer than that, but the math doesn't lie. It's not necessarily drawn to scale. So here's the only example where we have to find the angle. It says find angle A. So if you want to find angle A, then you're just going to set it up like this. A squared equals B squared plus C squared minus 2BC cos A, right? And we're trying to solve for angle A. Now on the very first slide, or one of the first slides, I did rearrange this for you already, so that's fine. You can do it just like that. But I'm going to sub these values in myself and get these because I don't have that memorized. I just do the algebra every time. So side A is opposite to angle A. It's going to be 26 squared equals B, which is 29 squared, plus C, which is 34, that's squared, minus 2 times 29 times 34 times the cosine of angle A. So this and this are going to be moved over to the other side and be negative. So it's going to be 26 squared minus 29 squared minus 34 squared equals negative 2 times 29 times 34 times cos A. So I just moved the 29 squared and the 34 squared over. I'm going to work that out so that I don't have to deal with it anymore. So 26 squared minus 29 squared minus 34 squared equals negative 1321. Negative 2 times 29 times 34 times cos A. Now I'm going to work this out and get a number. So it's negative 1321. So that's going to be negative 2 times 29 times 34. And it makes negative 1972. And don't forget, there's still a cos A. Now we're getting there. Now it doesn't look so hard. Divide both sides by negative 1972. That gets rid of that. And I'm going to type that in right now. Negative 1321 divided by negative 1972. And it makes 0.6698 and some other stuff equals cos A. So the last thing I got to do is I got to do that second function cos in order to solve it, and that'll get rid of that, and then it'll just be A equals. So keep that 0.6698 on your calculator and just take the shift or second function cosine of that number, and you get an angle of, I'm rounding to the nearest angle, and that's 48 degrees. All right. That is the different combinations that we can use cosine law for. I'm not going to do that last one with you right now. Let's keep my annotations. I will post some work with answers to it to test whether or not you still remember to do that. Handing it in to me will be optional. But if you do hand it in, I'll mark it and get it back to you. Okay. That's all for now, guys.